he has received numerous prestigious awards, including the Hong Kong University of Science and Technology School of Engineering Distinguished Researcher Excellence Award in 2025, the American Society of Civil Engineers 2021 Award, 2020 Frank Masses Transportation Engineering Award, and 2011 State Natural Science Award presented by the State Council of China. He has been appointed as a Changjing Scholar, a chair professor at the Ministry of Education of China, and served as the editor-in-chief of the flagship journal of Transportation Research Part B, Methodological. We all know that that's the top journal in our field. So he has been the editor-in-chief from 2013 to 2018, and I believe that now also he's on the editorial board, and he currently holds the position of honorary editorial board member of the journal and serves on the scientific committee of Transportation Research Part C. Yeah, so with that, Professor Yang, I hand it over to you. We are very looking forward to your talk. Thank you.
Okay, thank you, Annie, for your introduction. Now everything okay, right?
Yes, we can
Okay.
see your
So
screen. Yeah, over
yeah.
to you.
So first, I would like to thank the committee, for inviting me to speak to you today. So I'm happy to talk to you about the how to build the urban air mobility. Okay, we will look at the opportunity, challenge, and also policy public perception. Okay. Uh, I will divide my presentation into four main parts. First, I will talk about the current status, trends, and the challenge of the now-altitude economy. Second, I will share some of the research our team has done on this emerging topic. And the third, why my slide didn't come out? Sorry.
Oh, yes.
So
You were
what's
sharing,
problem?
but then can you share again?
Share, okay.
Share
Now,
screen.
now okay?
It is loading. Yes, now we can see it. Thank you.
Okay.
All good.
Okay, and okay. Uh, in my third part, we will focus on the key issue for developing the now-altitude economy, particularly in Hong Kong. And finally, I will introduce a major policy research project we are working on and share our main policy recommendations. Okay, this is part one. Yeah. The now-altitude economy, or LAE, is a new and important area. The Chinese government has given strong support, in recent years. In 2021, it was first included in the National Transportation Plan, and at the end of 2023, the government identified LAE as a strategic emerging industry. And in 2025, the government issued a classification system to define what is included in the LAE. And most recently, early this year, the National 15 5-year plan emphasized the need for safe and orderly development of this sector. It was recognized as a penal industry. So this indicates that the government is really serious about building this new economy. So what can the now-altitude economy really do? The possibilities are very wide. As you know, it can be used for passenger travel, like air taxi and flying taxi, uh, delivery services, and infrastructure inspection, and precision farming, public service, like emergency responses, and also even environment, entertainment, okay? Many examples. So the potential applications are very broad. Uh, the industry is already growing very fast. By some estimation, the value of China's now active economy has already exceeded the 850 billion renminbi. Okay, this is really a huge number. We can already see many applications in our daily life, like drone food delivery, agriculture drone, and the recent, in Guangxi flood rescue, just about 1 month ago. So this strong growth is being driven, okay, by expanding use cases and more government policy support. The Guangdong, Hong Kong, Macau, Greater Bay Area is a very important region for the now attitude economy in China. Okay. Most of you may, I think you know the Greater Bay Area in China. Okay. This area is the home of about 90 million people. It is a leader in this field in China. Okay. For example, 90% of China's drone export come from the Greater Bay Area. And the Greater Bay Area also hold more than 70% of the global consumer drone market share, like Dajiang. One company, Meitan, has already used the drone to deliver over 200,000 food orders here. As I mentioned that the data already outdated. So the Greater Bay Area already has a strong aviation network and a growing ecosystem for LAE companies. When we think about developing this new air transport system, we must remember, the 7 key principles. And first and most importantly, is safety. And this new form of transport must be as safe as traditional aviation. And second, it must be sustainable and good for the environment. And third, there must be equity access. It should not be a service only for the rich people. Everyone should benefit. And the noise is also very important. We must consider and reduce noise for the community. And fifth, this industry will create new jobs. So we must focus on local workforce development. And six, it should connect well with other transportation options like train, buses, and ride-hailing car. We need multimodal connectivities. And finally, we also need the policy-driven data sharing to help service providers respond quickly to passenger needs and the market demand. The principle should guide our planning of now attitude economy. Of course, developing the LA is not easy. There are many technical challenges. We need to build the right infrastructure and investment in such infrastructure, like a vertiport charging station. We need a reliable positioning system for drone or eVTOL. We need advanced control and navigation system. We also need a sensing and communication technology. And we need a 3D GIS-based platform to manage the airspace. And we need to plan efficient routes and schedule for the for the flight. All the area these are areas where we need more research and development. A modern now attitude mobility system requires integration of the four subnet four networks. You can see the concept in this diagram. The key is to combine ground infrastructure, communication network, digital airspace management, and service platforms into one seamless integrated system. Now, I move to the second part of my presentation. In this part, I will cover some of the theoretical work our research team has done. Let me share two examples. First, we have worked on the on designing drone services for monitoring cities and inspecting infrastructure. These slides show the planned flight routes for urban monitoring. Another example is to use drone to inspect the subway facilities. And this is efficient and safer than just sending people. Okay. So in our research, we optimized the location of depot and the road for the drone. Second, we have done some work on urban delivery. One key area is using truck and drone, together. For example, a truck can carry a number of drones. It acts as a mobile depot, and the drone can make a shorter delivery from the truck. This is efficient. Is in some scenarios. So we have also worked on design delivery network specifically for the drone depot hub and the delivery point. Okay. I didn't go to the details. If you are interested in our research, you may refer to the paper which I already published. Okay. Now let me explain one of our key research focuses in more details. An important factor is that a drone's energy consumption depends on the weight, the payload it is carrying. So a heavy package uses more battery powers. So we have developed an advanced model to account for this. Okay, so we have to count the load-dependent drone. So we have also developed a powerful algorithm to find the best route and the best places to put the harbors. And our finding show that using accurate energy model can improve efficiency. And placing hub in the right location is important. And our algorithm can also solve large and real-world problems effectively. Okay. I think 16. Okay. We also designed a network for drone delivery that consider uncertainty with uncertain demand. For example, the weather can change, making some airspace unavailable. Customer demand can also be unpredictable. So we developed a model to handle such uncertainties. It is called distributionally robust optimization models. we tested this model with real urban data and demonstrated that it was more reliable than traditional model, and it can maintain service levels even during demand surge or bad weathers. In another project, we also looked at systems where drone and the ground vehicles work together. The drone fly quickly, and the ground vehicles handle the final delivery. So we considered real-world constraints like delivery time windows and the ability for vehicle to make multiple trips. Our model calculates the best hub location, the ideal number of drones and vehicles, the fleet size, and the most efficient route. The key benefit, are lower cost, more reliable delivery, and better use of resources. Now, I move to look at the third part, the key issue for developing the low-altitude economy in Hong Kong. Okay, to develop the LAU, we need a clear framework, and this diagram shows the key component of the framework and the roadmap for the development of low-altitude economy. It involves technology, infrastructure, regulation, market demand. All these parts must work together. So based on the framework and the roadmap, we have to deal with some key issues in LAE development. The first key question is, what is Hong Kong's position and strategy? As you may know, Hong Kong is strong in international standard and connections. And we believe Hong Kong can serve as a global connectors. So this means three things. Exporting Chinese mainland the technology and the standard of low-altitude economy, and also becoming a demonstration zone of cross flight. We still have a border between Hong Kong and Shenzhen in mainland China. And also attracting international capital and talents to support development of this industry. The second key question is, how do we move from a policy-driven approach to a demand-driven one? The current low-altitude economy is mainly driven by the government policy, through subsidy and some other policies. So demand is the engine of growth. It is the key to making the LAE sustainable in the long term. We should focus on high-value application first. In Hong Kong, this could include things like we have many island monitoring, inspection, and medical delivery, and emerging rescue and disaster response. And also public service support. So by starting with these areas, we can build a strong foundation and demonstration values. The third key question is, what is the role of the government? The government should not just be a regulator. It should also be an enabler. The government should set up clear policy and regulations for the for infrastructure and operations. It needed to balance the interests of the government, the business company, and the users. And of course, the goal is to maximize the overall social benefit. So finally, I will tell you about our major policy research project and our main policy recommendations. Okay. We are very pleased to have received funding from the Hong Kong SAR government, Strategic Public Policy Research Funding Scheme, or SPPRF. This is a 3 years project that already started in January last year, 2025, and we will run until the end of next year. The project is titled Development Strategy for an Advanced Air Mobility Network in the Guangdong, Hong Kong, Macau, Greater Bay Area. I mentioned, this area, this leading area of a development in China. Okay. Of course, this is a very important project for us. And we have a multidisciplinary team from Electrical University, my university, and other university. Okay. Hong Kong Poly U and Electrical University Guangzhou campus. Okay, I'm the PI. I have joined by colleague. Okay, from different field. Okay, in civil engineering, aeronautical engineering, information system, and social science, public policy. So this diverse expertise is essential for tracking the complex challenge of ARAE. So the main goal of our research is to design, analyze, and evaluate the advanced air mobility system for the Greater Bay Area. We also wanted to give the government a comprehensive view to help government make better policy and regulations. So our 3 specific objectives are, first, to analyze the demand, market structure, and the regulatory framework. And then to design the infrastructure network for efficient services. And then to build a simulation platform for the Greater Bay Area to test different scenarios and find the best solutions. Okay, this will allow us to provide the data-driven advices. To achieve the objectives I just mentioned, we have a clear research strategy. This involves a series of tasks, including data collection, model development, stakeholder engagement, and policy analysis. Okay, and we are taking a scientific and systematic approach for this project. We have already done a lot of groundwork. First, we visited over more than 20 now-altitude economy companies in the Greater Bay Area. We talked to companies like Yihang. This company is developing eVTOL, Fengyi UAV, for parcel delivery, and Meitan for food delivery. Okay, we learned about their technology, operations, and challenges. And second, we conducted a large survey of residents in Hong Kong and the other Greater Bay Area cities. We collected over more than 3,000 valid responses, and we asked about potential users who needs to use AAE services, their concern, and their price sensitivity, and so on. So the data is crucial for understanding user needs and building realistic models. So based on our research, we have developed a set of policy recommendations, from the perspective. From the perspective of the industry, We have three major recommendations. First, we recommend the regulatory alignment and sandbox optimization. Hong Kong SAR government approved, I think, 38 sandbox panel project, okay, 1 year ago, and most projects have been successful. So specifically, we needed to update the law to include, larger aircraft, and we should expand the sandbox program and create a centralized online platform for flight applications to make approval faster and simpler. We also need a cross-border task force to work with the mainland city on mutual recognition of license and unified standard. I think the government is doing this. This will simplify administrative procedure and encourage innovation. Our second recommendation focused infrastructure investment and unified platform management. The government should invest in key facilities like a vertiport and charge stations. Hong Kong should develop a unified citywide digital airspace management system. This system should be able to integrate data and automate flight approvals for all operators. And the government should facilitate collaborations between industry players. This will create a solid foundation for the industry to grow, okay, in the long term. And third, we need a strong focus on talent cultivation and development. We should expand academic program and offer specialized degree and certification for pilot, technician, and managers. We should launch, also talent exchange program, particularly within the Greater Bay Area cities. And we should make it easier to attract global experts to Hong Kong. This will support the long-term growth of the industry. Now, let me look at the look at the recommendations, okay, from the customers' perspective. I mentioned our earlier SP survey. Our survey gives us a clear picture of what users want. First, customer want better connection and fast cross-border, like cross-border check process procedures. We should also locate a vertiport at a major transport hub and provide a good connection to get people to and from the vertiport. We should use digital tools to streamline check-in security and customer. The government should set targets for reducing the total time passenger spending in such procedures. So speed and convenience are essential for customer adoption and for the overall efficiency of the now attitude mobility. Okay, okay. Second, customer need to feel safe and secure. They also care about their privacy and comfort. So the government should enforce strict safety standard and request operator to have a public reporting system. And we need a clear rule on data privacy and measurable standard for comfort and noise. These steps will help build public trust and acceptance. Third, we should deploy services in phases and then tailor the services to different user group. Don't try to do everything at once. Okay, we should start with the crowd where the need is the greatest, like business travelers, where saving time is very valuable. And then as the technology become more reliable, become mature, we can expand to other area, other part of the city or other customers. This phased approach reduce risk and they allow the industry to learn and grow. Finally, and importantly, we must promote equitable access. We should avoid a premium only model. The AE should be regarded as a service that strengthens the overall transportation network. We can start by serving areas with poor ground transport, where the air service can make a bigger difference. Okay. You in the Greater Bay Area, we have a number of major international and national airport. So if we can use elevator to connect all the airport, it should be very helpful. Okay. Okay. So the goal is to use policy to foster the market and eventually make the service available to the broad public. This will ensure that the benefit of the now-active economy are shared widely. To close, I wanted to show you a demonstration of our advanced 3D air mobility simulation platform. Okay, this platform is a key tool for our research. It allows to model the future AE network, test different policy, and visualize the outcomes.
Professor Yang, does it have an audio? Because the audio hasn't been shared, just in case.
Audio not shared.
Yes, so when you're sharing a screen, yes, when you're sharing a
I
screen.
don't know how to do it. Just music, I think that is okay.
Okay, all good.
Audio. I think okay. Sorry, I don't know how to share the audio of my
Oh,
video.
so
But anyway, just
yes.
music, just
Uh-huh.
background music. I think I don't think you miss
Okay, that's
anything.
just music,
Okay.
then that's fine. Yes.
Yeah. So okay. So that's all of my talk. Thank you very much for your attention. Yeah. So I saved a
Thank you
lot
so
of time,
much.
right?
Yes, which is good actually, because we have a few questions in the chat box, and I encourage everyone to please post your questions or even your thoughts, or if there is any news that you're aware in your country, or any interest, anything basically in the chat box. So, Professor Yang, thank you so much for your insightful presentation. We have a few thoughts and questions shared in the chat box. Professor Kara Kuckelman has asked how much more
Okay.
energy cradle to grave and cost in terms of operating cost plus capital cost per passenger kilometer is eVTOL likely to be compared to ground modes. For example, you know, like autonomous vehicles or the other basically ground modes at the same seat occupancy level. Do you have any insight in that?
Yeah, I don't have specific, don't have a really practical answer to this question because the air mobility is not really in implementation. We don't have real data. But based on my visit with some major company, I can share something. Uh, I talked to the Yihang, the developer. They conduct a market survey, and if they can have about 1 or 2% of market share, I think the company maybe they can sustain. In terms in terms of the cost, the cost. I don't have the specific data. Actually, we are now developing we already moved to the second stage of our project. So we are now collecting data from different sources to try to make our model as realistic as possible. Um, but Okay. From passenger perspective, from our survey, I found of course we know the air mobility is mainly for flight for time saving. Flight time saving, in-vehicle time saving. But they care about very much the first mile, last mile connections also. So the overall time saving is critical. And we also found, under any scenario, no matter what, how much time saving or how cheap the air mobility, some passengers just simply don't consider use of advanced air mobility. There are such a group of potential the customer. I think this is an interesting question. This means our traditional district choice model, knowledge model may face some new challenge. How to consider such a group of people who don't consider, the use of air mobility. Maybe Maybe after the technology become more reliable and mature, more people will consider adoption of this new technology. We are now developing. We're now using large language model, in combination with the traditional district choice model to consider this phenomenon. That's what I can share with you. Thank you for the
Yes,
question. I
yes.
think this is a really good question.
Yes, so I reckon that actually it's very similar to the autonomous vehicles about a decade ago, or basically 2 decades ago, that it seemed very luxurious mode of transport, very expensive. But then as the technologies and sensor technologies are advancing, the price also goes down. I reckon that it was the case a few centuries ago with the airlines, and compared to train and buses or vehicles, so even horses. But
Yeah.
yes, car actually has rightfully mentioned that perhaps it could be about like 4 times less energy and cost effective compared to um, uh,
Okay.
shared autonomous vehicles, but then also twice as fast because it can actually provide. I think Kara actually mentioned the other, like Kara, if you are there, please unmute yourself. What you meant was that shared autonomous vehicles perhaps are 4 times less energy and cost effective, right? But then they also provide door-to-door services.
Well, right. So I don't think they provide door to door, but vehicles typically, but not aircraft. So unless
Yes.
you're dropping off your own dropping off,
I think in terms
the
of
door to door
energy,
access and egress.
I
All
think
right. You were dropping off Kara, but what you meant was the air mobility perhaps is not really door to door, so still you have access and egress. That's what you meant? Your
Yes.
voice was dropping off. Yes. Gotcha. Prof Yang, if there's any point to add to that.
Just wait. Okay. I think where I cannot. Now let me check the question. So what's the next question? Let me check.
Oh, yeah. So the next question, Gian has mentioned that as a passenger transport mode, air mobility is likely to be a very more expensive mode, but fast alternative, yeah, for modes like taxi. So how is the equity issue dealt with?
Okay. Now, before I answer this question, first of all, in response to the earlier question in terms of energy consumption, but here in mainland, more and more car, like taxi or even elevator, will be electric. So maybe energy could be less concern in the future. I'm not sure. As passenger transport mode, okay, air mobility is likely to be more expensive. Sure, this compared with other mode, but as I already mentioned, in terms of travel time saving, I think the first mile, last mile connection is critical. So the key question is how many vertiport should be located? Where to locate the vertiport? I think the first mile, last mile exit time depends on the density of the vertiport, right? And if you put more vertiport in the city, you need to do more investment, all right? And on the other hand, you can save access time. Yeah, that's also the issue we are looking at. In terms of equity issue, of course, as I already mentioned, maybe we can have a phased development. Maybe first we can target some business trip where travel time saving is critical, and and where needs to pay is high. And as the technology become more reliable, and we can expand the services to the other sector, other part of the city. In the Greater Bay Area, I think the one major consideration is to connect the major airport. And because most people in mainland go overseas by the Hong Kong International Airport. But actually, in this case, we have a dilemma. We have a physical question. Because the space near the airport is prohibited for elevator, right?
Yeah.
And
Yes,
you
yes.
have to locate your vertiport somewhere away from the airport for safety consideration. But on the other hand, this means this will increase the first mile, last mile extra time. We have such a trade-off. This is also the question we need to consider as a transportation planner, right?
Yes, absolutely.
Yeah, in the long term, I think equity should be considered seriously. But initially,
to allow the technology to progress,
yeah.
you need actually investments, and those investments should also interest some wealthier businesses and sectors. I believe that actually tomorrow that we have also headline talk by Tessa from Uber. We might actually ask these questions because I know that Uber and so many other operators are investing a lot in these things. From my point of view, as someone who lives in Australia, and also, we experience lots of natural disasters in Hong Kong. That's an issue as well, hurricane, cyclone, etc. For emergency evacuation, what we are struggling with is the basically emergency helicopters that are limited. There are just a few of these options available. I always thought that the air mobility, even if like the main purpose is for the commercial market, but if it's needed in events of natural disaster, at least they could be deployed. So that could actually provide more feasibility, at least for natural disasters like flood or bushfire, for evacuations, emergency evacuations. Those could be actually useful. So it's not only like, very, very luxury option now. there could be some benefits for the society later on.
Yeah, I fully agree with this really happened. I mentioned just about I think just 1 month ago we had a serious flood in the Guangxi province. They really deployed uh, drone and elevator for the rescue, and this really benefited the ordinary people. All right.
Yes, absolutely. And there's
Yeah.
another question from Ipstia. So the question is, are there parallel studies on policies and pricing structures to manage demand for excessive individual transportation once this technology scales? So basically the question is about, is there any parallel studies on policies and pricing structures that you
Um.
might be aware of?
Yeah, in this summer, I attended quite a number of conferences, particularly in mainland. I see, you know, the conference always have, sessions on the now attitude economy. Of course, a lot of research on the pricing, particularly on the air mobility network design. But I found, we are lack of real data. So I think the approach is still just based on traditional modeling. Uh, yeah, the problem is we don't have real data yet. But I say a number of study just based on SP survey, yeah, then do some choice analysis. The pricing structure. I really have no idea because we don't have real deployment. We just have some testing, of eVTOL transport. So maybe
Yes.
based on maybe linear pricing structure, or I don't know. Maybe non-linear. I don't know. Like our maybe high-speed railway structure. Uh,
Yes.
I
Uh,
have really have no idea, for in the future how what would be the price structure, linear or non-linear. Yeah,
I think basically pricing strategies will be dictated by the operators. There could be some regulations,
yeah,
but I reckon that, in free market countries like Australia or Western countries, even like regulation will be more focused on safety and security aspects, not really in terms of pricing. I reckon pricing might not really be regulated. There could be some studies that I
yeah,
reckon that the basic operators, the air mobility operators, they themselves actually might do some of these market studies in terms of pricing.
yeah.
So one question, I'm cautious of time. The next question is by Gian. I read it, Gian, but then again, you feel free to ask the question yourself. The question is, how is the port access and egress dealt with when the port is located at the top of buildings? It is particularly very important for Hong Kong that you have lots of skyscrapers, top buildings. So from the basically point of view of building managers, is it feasible, alternative, or even attractive to building managers?
Oh, I think this is a good question. In Hong Kong, we have many high-rise building, and using the roof could be the roof could be a potential vertiport. But I indeed, we had such a discussion, and some people even mentioned, within certain range of the space, it's a private space. You cannot really build set up a vertiport. Uh, um, it, I think in addition to the building, the top of the building, we may also consider location like near train station, and also the near the airport I mentioned earlier, some potential uh vertical locations. Yeah, building could be certainly a consideration. But in Hong Kong is a special place. Okay. If we consider vertiport, connection to the mainland China, we need to have some immigration check. Those is just a simple, very important facility for taking off for landing. We have to consider such other affiliated facility and also charge station, right? Charge stations. Yeah.
Yeah, charging stations are important as well. I know that there are a few studies, and Professor Young, you also mentioned about operation around airport, the international airport, that because of the safety issues, is restricted for the private air mobility operators. Perhaps now the regulation might change, but yes, as I'm also aware of regulations here in Australia, there have been a few studies and basically exploration whether the regulations should be amended to allow the operation of air mobility in the airspaces. The main challenge that I've heard from some researchers who work in this area in Australia also is basically the airspace so basically which vertical area is allowed for the private operators, the competition between operators in terms of the safety allocation of the airspaces. Even for drones, also we have such challenges that there have been lots of studies, very isolated, fragmented, but not really,
Yeah.
harmonized, I would say.
Yeah.
So perhaps we can also address the last point before we run out of time. So this question is from Bar Hewis. If event facilitators, please put in the. Oh, sorry. that was a comment for the for us, basically for the organizers. So if you have any question,
there was another one, Ellie. If you go a little bit higher.
Oh, right. Yes. From King Yang. Yes. So how has the low altitude economy changed airspace allocation? How is this currently implemented? For example, how is it configured in simulation platforms? Is there room for improvements or not? Great question, Kuan.
Yeah. This really this I think this is somehow technology issue. And for our study, we consider a passing air mobility. We didn't consider the multi layers yet. And in the future, we could have a multi-layer network. Maybe the no layer could be for delivery, parcel delivery, and the above that could be for passing. I don't know. Yeah, this really technology issue. And we have more, if after we have more and more flight, I think how to resolve the conflict, this could be a key concern. In terms of airspace allocations. Okay, I think the safety is a major factors. But nowadays we don't have a high demand flight. So mainly just some major company like Meitan and Shunfeng, and they apply for some flight route, some corridor. They can easily get approved because we don't have congestion yet. But later on, as more and more operator enter the market, and definitely we need to have a unified platform and procedure, to approve the flight and consider airspace allocation for both freight transport and also passenger transport. Yeah.
Right. Awesome. Okay, so we are actually on time. Thank you so much, Professor Yang. I have to also apologize that we didn't have transcript before. I noticed from one of the comments that for the accessibility issues, we make sure that we enable transcripts. The good news is once that we upload all of the videos on YouTube channel, we will definitely put the transcript so you can listen to the recording later on. But also thanks for the heads up. And thank you so much, Professor Yang. Very interesting talk. So we are closely following what's being done in Hong Kong and China. And everyone, please also look at the chat box. There is a link for the other parallel sessions. So we have the other 3 sessions, but also we continue here in this Zoom for the next session. So that actually we can, the first one is ride-hailing and emerging mobility. For this, Gian will be the chair. You don't actually need to change the Zoom room. Please stay here. For the other one, freight transport, and I believe that actually Anissa has posted all of the Zoom links. You can find a link and change the room. Okay, so with that, then